Hey guys, so today I'm going to be talking about the power distribution on my autonomous RC car, how I power each part of the system, the problems I ran into on the way, and why getting it right is so important. I'll start by showing the full circuit diagram, and then I'm going to walk through how it's actually set up on the car. But before we look at specific components, I just want to talk about how important it is to power your components correctly. So in electronics, every component is designed to take a certain amount of voltage and draw a certain amount of current. So if you don't provide your components that exact voltage and current that it requires, then your parts are either not going to work correctly or they can simply just burn out and fry. Alright, so right here we can see three very important components of the car. That green Raspberry Pi in the middle is our central computer that processes the LiDAR information. Now that Raspberry Pi is powered by a 5-volt 3 amp portable charger, like a power bank, one of those that you charge your phone with, via the USB-C port on both the power bank and the Raspberry Pi. Now the Raspberry Pi does operate on 5 volts, and just because it's getting supplied with 3 amps, it doesn't mean that it's going to specifically draw the full 3 amps the whole entire time, but it's good to give some extra current available in case you're under more load. Now you can see from the USB port on the Raspberry Pi, we are powering the ESP32. The ESP32 is the microcontroller you see sitting on the breadboard. Now the ESP32 runs on 3.3 volt logic, but because it has an onboard voltage regulator, it handles that 5 volt to 3.3 volt for us. Alright, so as you can see on the car, that's the 5 volt 3 amp power bank. And from the USB type A, I made a mistake. On the video I said type C, but it's type A. It doesn't matter, same thing. It's powering the Raspberry Pi right here on the USB-C port. And from the type A USB port on the Raspberry Pi, I am powering the ESP32, just like I mentioned in the video. So you have that right coming all the way here and powering up the ESP32. Right, so right here you can see our ESC, our electronic speed controller, which controls the throttle on my car, is powered by a 7.4 volt LiPo battery. Now the ESC is rated for a 2-cell LiPo, which comes out to be around 7.4 volts. So that works just fine. And my the BEC is a battery eliminator circuit, and what it does is it gives out a lower voltage, in our case 5 volts, to power other components on the car if you'd want. You don't need to use it, but it's there if you want to power something from the ESC. Um, so what I did is I tried powering my servo with that 5 volts. I was like, you know what, perfect. 5 volts, that's what the servo wants, easy. But not quite. So what ended up happening is when I would steer my car, I would actually twitch the ESC and some throttle would get sent. And that's not what you want. If you're controlling the servo, nothing else should happen. So I was like, okay, there has to be some like signal interference here. One should not be affecting the other. So I decided to go a different route and power my ESC and servo individually with their own power sources. So I'm going to show exactly how I did that. And I think that was the best decision I could have made because now I have no problems. And if I do, I know exactly if it's coming from the ESC or the servo. Okay, so the ESC I was talking about, the electronic speed controller, is going to be right here. And that's going to send commands to the motor, right? The motor back here via these banana plugs. And my ESC is powered by that 7.4 volt battery I was talking about. That battery is located under this one. So under this power bank, the one I showed earlier, we have the 7.4 volt LiPo, and I can just plug that directly into my ESC. And there you go, that's power for the ESC, so that works just fine. And I was talking earlier about the BEC, and I wanted to show you guys where that is. So if you look closely right here, this is that 5 volts, that red wire in between. That's the 5 volts that you get from the ESC. I tried using that to power my servo, and again, things went horribly wrong. I was getting really weird mixed signals, so I scratched that, and I am now not using that 5 volts completely. And This white wire right here, that's a signal. That's how my ESC gets commands from the microcontroller, whether that's drive forward, drive back, right? How much throttle to give it, that's where it gets its commands from. And then black is just ground, and that goes directly into the microcontroller as well. All right, so now we're looking at how I powered my servo, because I just told you I didn't power it with the BEC anymore because of those problems I was getting. So the servo wants 5 volts. Now I can't get a LiPo for 5 volts, so what I did is I got a 7.4 volt LiPo battery, and instead of course, powering it directly to the servo, you can probably see what would happen if I gave the servo 7.4 volts. So what I did is I got that green device in the middle called a buck. And what that does is it steps down the input voltage from 7.4 and it outputs Vout 5 volts. You can see that red wire going from the buck to the servo. That's the 5 volts, and that's exactly what my servo wants, right? So that eliminates the servo getting way higher voltage than it wants and probably burning out my servo. So that buck is perfectly used right in between, and therefore my servo will run just fine. Alright guys, so here you have it. We talked about the power distribution on my car, and again in front of you is the circuit diagram that I designed, and in future videos we'll get into more parts of this circuit like input output and ground, but that's going to be it for today's video, so stay tuned for the next. Bye.